All right, hey everybody. We're back for the second part of the Prusa build live stream. So last night we left off with the frame. We've got that kind of put together. We stopped on step 11 and we're going to try to get through the y-axis today. So we're on step 12. I've got all the parts kind of laid out on my mat back here. We need two Y holder fronts, two Y holder back, M3 by 10 screws, and M3 square nuts, 8 of each. So we've got everything laid out. That's step 12. For step 13, we're going to take the front and back holders and insert the square nuts, and I think that's it. Okay, it says you just stick them in, make sure they're flush with the top. Don't force them. Make sure there's no obstacle in the way. They should just slide in. Okay, they do. They just pop right in with slight pressure. I'm going to use an Allen wrench to try to stick it right through the hole here and press down, and that helped me pull it the rest of the way in. Not too bad at all. Okay, that went in really easily. I think for now I'm going to move the frame over to the side so you can see what I'm doing on the mat. I think I'll just put this on the floor for now until I need it. Okay, got that one done. Some of these slide in easier than others. Okay. And just like I did with the last one, I'm going to reach in with an Allen wrench and try to line up the hole. There we go. Another one down. Easy. And I can see the surface finish on the bottom of these prints. Looks like they were printed on the new powder coated spring steel sheets. So these were probably printed on the production Mark IIIs. It's not quite as smooth as just a plain PEI sheet, but it's not bad. It kind of reminds me of the texture on some cameras, like the rubberized texture. It looks kind of like that on the grips on some cameras. Okay, so I've got the holders, got the square nuts inserted. So we're on to step 14. So I need the frame back. Okay. Okay, so the longer ones, we're going to start with the front, and I gotta be able to distinguish. Okay, the front Y holders have a little tab on the front edge there. Let's see, okay, that little tab right there, that's what distinguishes between the front and the back. And it looks like the tab faces the front plate, and they go just like that on both sides. So the tab is down, and the circular part faces the frame. Oh, this is really cool. Okay, so I'm going to show this in the instruction guide on my iPad. Okay, if you can see this, everything's backwards, so bear with me. Whenever you're ready to change to the next picture, you just click on it and it automatically updates. So that's a really neat feature. And then you can just pinch zoom. So if you do have a tablet, I recommend using your tablet to help you put this together. So then you just rotate them up, just like that. The tab helps you align it on the aluminum extrusion. You just rotate them 90 degrees and kind of push it down in there. And then they take two M3 by 10 screws each. So I'm going to turn it around towards myself and put those in. And it says to tighten both screws equally but not completely. We will tighten them fully later on. So we're just going to get them finger tight. One down, so the right side's done. Moving on to the left side. And then we'll do the same thing on the back for the back holders. Let's see if I can find a... This is where the pinch zoom really comes in handy. So there's an angle on the front edge here, and that angle faces towards the frame. So that's how you orient your back holders. I've heard some people complain about the print quality, but so far I don't see any issues. These all look really well done. PEI, not PEI, PETG can be kind of tricky to print with, and there are some, tiny little spider webs here and there, but that's just the nature of the beast. It's a minor inconvenience. On my FT5, that's what I printed all of my frame brackets. It comes with melamine parts. It's kind of like compressed wood fibers. And down here in Texas, the humidity swells those up quite a bit. So I replaced all the frame brackets with PETG. It's actually the Color Fab, I think it's XT. And that stuff is really tough. And it worked out a lot better. My frame stopped creaking as much. Okay, so I've got all those put in. Now I'm on to step 15, the Y-belt idler. Okay, so I'm going to move this up out of the way so I can get to all my parts. We need the idler. I've got that here. We need the, let's see, no, the idler, 1 M3 by 18, which is the long one, and 2 M3 by 10s, and then 3 nylock nuts, and the bearing. Okay, got all my parts. Now we can put it together. So we need to insert the nylock nuts, and so these can be tricky to do, especially if you don't have any little tiny pliers. So that one just jumped right in there. And what you can do, I've seen this on a couple of other streams, is you can take and thread in the backside a screw and then just tighten it on down, and it's going to pull the nylock into place.
One of your webcams is frozen.
Okay, so one of the webcams is frozen. I've just been notified. I'm going to do my best to get that fixed up. Not sure what happened. I don't know if I can fix it during the stream, but the main cam seems to be functioning. It's just the mini webcam. Okay, so I've got that all pulled into position, and I'm going to pause here a second once I get this back out, this screw back out, and try to fix this webcam. Okay. Okay, it should be working now. Hopefully I'm back up. So let me know if it freezes again, and I can try to fix it.
You're back.
Okay, good. I just realized that you guys can't see what I'm doing because my hands are behind the frame. So I'll try to keep my hands in frame so you can see what I'm working on. I can move the frame out of the way for a second. Okay, so all I'm doing here is pulling this little nylock into place by screwing this in from the back. But you have to make sure that the corners are lined up with the corresponding hole, so you can just kind of wiggle it, and then it should seat into place eventually. There we go. And once it's in, it's in there. You shouldn't have any problems with these things falling out. And then you can just unscrew the socket head cap screw. I really like how all the 3D printed parts look like they have version numbers printed into them. That's a pretty smart idea. So it looks like I have version A9 of the idler. Okay, so I've got that in. Don't use excessive force. And then they say take the M3 screw and thread it in from the opposite side. Yeah, and you don't need to tighten it down that much. Okay, and then one side has the counterboard hole, which is for the nylock, and then that just sits right in there, and then the longer socket head cap screw will fit through, and it's also got its own counterboard hole, but it's a circular counterboard hole, not hexagonal. And then the pulley or the bearing just fits right through there, and then you can tighten up the cap screw. So this looks like a pretty robust solution for a bearing mount. You got to make sure when you're threading this in that you don't push out nylock and make sure that you have some threads engaged with the nylock. Okay, I'm engaged, and then this still rolls. So we're in good shape. Okay. So now we're going to mount this to the frame with these two guys, the M3 by 10s. And so this mounts to, let's see, place it on the front plate. Note there's a mark, a circle printed on the part facing up. So that's really nice. They have indexed the part for us. So I'm going to turn the front of the frame towards myself, and the part is indexed with a little dot up in the top corner, which makes it really nice. You can't put it in upside down if you're paying attention. It says do not tighten the screws fully. We need it loose so that we can adjust the tension on the belt. So I'm going to back those off a little bit, make sure it's loose, make sure I can wiggle this around. Okay, good. So that's loose. Okay, I'm ready for the Y-axis motor and motor holder on step 19. So I need 4 M3 by 10 screws, 2 regular nuts, not the nylock nuts, just the regular. So I've got 4. I'll move those over to this other side. 1, 2, 3, 4. And then I need 2 nuts, M3 nuts, the Y motor holder, and then I need the Y-axis motor. So it's over in a box. And it's actually laser engraved Y-axis, which is really nice. So let me go dig through and find my Y-axis stepper motor. It's over here on this other table. Okay. Well, this is really nice. They have even a little identifier on the cable that says Y, and then it looks like it's laser engraved Y-axis on the stepper itself. So attention to detail, the little details like that make it so much easier to put everything together. And it looks like they probably have this cable coming out the back is probably just the correct length, just the exact length that you need. And these wires are all twisted together. Sometimes the wires coming off the stepper are just kind of loose, and you have to either braid them yourself or use some sort of wire wrap, wire management. And so this is nice that they're all kind of bound together. They're not going to go everywhere. Okay, so I've got all my parts out. Yep. So I've got to do the same thing, put the nuts in the little counterboard holes on the holder. Looks like I stuck it in there kind of crooked. It didn't really seat. So I may have to use that same trick where I use a screw and reach up inside there and grab a hold of it and get it threaded down in there. So these parts are really like neon orange. In all the pictures that I've seen, I just assumed it was like a regular orange color, but these are super bright. I would have never expected these to be so neon orange colored, but I like it. I like orange. Orange is one of my favorite colors. Okay, there's one. Get the other one in. Well, that one just popped in. Cool. Yeah, some are easier than others. So I've got those put in, and now I'm going to mount this on the motor. So I'm going to orient it just like you have in the picture. I've got the wire coming out towards me, and then this bracket on this side mounts over the stepper motor, and I secure it in the corners with 2 screws. And these are nice counterbore holes. It looks like I missed. Let me try that again.
We have 5 on the stream.
All right, if you're just joining us, welcome. Feel free to ask questions in the chat. We're just here building this Prusa. Got to remember to pronounce it correctly. Okay, there we go. Got those put in. And then we're going to mount it to the frame on the back. So this is the back, so I'm going to turn it around so I can get to it easier. There we go. And let's see. The motor wire is going to go off to my right, like in the picture, and I need 2 M3x10 screws. It says to take note that the power supply T-nuts are on the left. So got that. So the shaft of the stepper motor must be facing the power supply. When I put these in, I always put the top one on first so I can let go, and it just kind of hangs there, but I don't tighten it up all the way, and then I put the bottom one in. That way I can pivot it back and forth and line up the holes, and then once I get the bottom one threaded in, I go ahead and tighten it up. And it says secure the Y motor holder with the 2 M3x10 screws. So I'm going to go ahead and tighten those up fairly snug. Okay, so now I'm ready for the Y-axis Y carriage. So I'm going to put this off on the floor for now to clear up some of the space. So I've got the Y carriage here. So I need the Y carriage, I need 3 bearings. Let's see, the belt holder, check. 3 VU bolts, check. The linear bearings, 6 nylock nuts, and 2 screws. And it says for MK2 owners, the Y carriage is now symmetrical in one direction. So the dot orientation for the bearing insertion does not matter. So that's good. They've made good improvements here. Okay. Oh, I just noticed something. So they have a list on the instructions. Let's see, let's get that up close to where you guys can see it. There's a list and there's colored dots right here. And the dots correspond with these colored arrows. So if you look at the yellow arrow, it's pointing to the linear bearings, and then it says the corresponding bullet point is yellow. So that's really handy if you're unfamiliar with these parts in general. a lot of time there's lingo and jargon used in 3D printing, and so if you're involved in 3D printing, it's no problem. But if you've never built a 3D printer before, you may have no idea what a linear bearing is. And so this is really helpful for new users. So I've got all of the parts laid out, and it says when placing the bearings on the Y carriage, make sure they're oriented as they are in the picture. One of the tracks has to be in line with the cutout for the bearing. Okay, so let's open up one of these guys and figure out what they're talking about. Okay, so there's 4 ball bearing tracks inside the linear bearing, and it says that one of the tracks has to be in line with the cutout for the bearing. Okay. I guess just like that. Orientation has to be followed for all 3 bearings on the Y carriage. Okay, so it looks like that's kind of vague, but based off the picture, it looks like the four tracks are all 90 degrees from each other. So it looks like you need one bottom center, like at 270 degrees, one at 0 degrees, one at 90 degrees, and one at 180. So they're all aligned with the 4 axes. I think that's what it's saying, but I'm not completely sure. Just based off the picture, I'm going to go with that. Okay, so very important. This influences the printer's behavior. Please read these instructions carefully. Okay, so place it on a flat surface. Orientation does not matter. Insert the linear bearing in the cutout and secure with a U-bolt. Okay, so this is really neat. They've actually included U-bolts, these tiny U-bolts. I think that they used to use, or the previous models used zip ties, so this is neat. Hold the thumb on the U-bolt and turn the carriage. Place nylock nuts on both ends of the U-bolt. Okay, so you hold it with your thumb, then you flip it over and put on the nylocks, tighten the nuts, be sure both nuts are tightened equally. Okay. So this, if you had a nut driver, this would be really handy to use a nut driver, a ratchet, or something like that. But it looks like I'm going to have to either use the my fingers or the needle nose pliers that were included. I do have a ratchet set, but I don't know where it's at right at the second. So I'm going to give it a shot with the, it doesn't say what to use in the instructions, it just says tighten nuts. Ensure both nuts are tightened equally. And stop as soon as you reach this surface. So, you know, you don't want to over tighten these because you might end up crushing the linear bearing. And I can understand why they didn't include a little nut driver, because it looks like this is the only time you have to use. You have to actually tighten a nut. I think I am going to go find my nut driver that would make this operation a lot easier. So I'll be right back. I'm just going to go around to the other side of the table and look for it. And hopefully I have one small enough. Okay, success. I found one. Just got to make sure I have the right size. So this is my little ratchet set. It's just a little cheapo. I know they're metric. If I can get this thing out of here. Looks like they may be too small for my ratchet set, because I've got a 6mm Yeah, it's too small. I guess it's a 5 millimeter. Well, I tried. Yeah, I think that's the smallest one I have. Okay. I will just use the needle nose pliers then. If you guys know what to use, please put it in the comments. Do my best not to scratch the surface of the carriage. So this is kind of fiddly. I may just turn the whole thing over like this. That way I can use both hands to steady the carriage. If you had a little crescent wrench, that would probably be better than trying to use these needle nose pliers. You could tighten it up with a crescent wrench. I have a feeling that my students are going to have a hard time with this. They would do a lot better with a nut driver. And I think we have a metric set of nut drivers at school, which is good. So I'm tightening both sides equally. I'm trying to make sure that my plier jaws are on the flats of the nylock. Which is difficult to do. I think I got this one tightened down pretty good. I don't think I'm going to tighten it anymore. It looks like the threads are engaged on both sides. This one is not quite as engaged, meaning the threads of the U-bolt are not sticking out as far on this side as they are on this side. So I think I'm going to loosen up this one a few turns and then tighten the other side a little bit, just so they're equal. Okay, that looks good. It's nice and secure. I'll move on to the next one. Again, I'm placing the bearings at 0, 90, 180, and 270 with relation to the carriage. So is anybody watching? Do you guys have the Prusa pre-ordered? And if so, when did you pre-order it and when do you expect it to come in? So I pre-ordered this one on the first day and it came in this week, I think on Wednesday. No, it was Tuesday night it came in. So this thing got hung up in Germany. They had a fiasco over there. I don't know what was going on. But it looked like all the ones that were going to the States got hung up in Germany. And then it got hung up in Kentucky. And then finally made it over here. And then I've got 5 more ordered for my classroom. And my students, my robotics students, are going to build them. And those are due to come in, I think I ordered those in November. And I think they're due to come in February. So that'll be good. Okay, that looks nice and even, and it's fairly tight. Let me tighten it just a hair more. It's a little bit wiggly. Okay, good. And then on to our last one. My wife is monitoring the chat, so if you guys have anything that you want to add, or if you have any questions, feel free to ask, and she's going to update me so we can answer your questions. If there are any other teachers watching, let us know what you teach and how you're using the 3D printers in your classroom. And if you're not watching this live, you can always leave a comment. So this week something really cool happened. I was in the Facebook group for 3D printing, and there was a teacher that had a, I'm not sure what kind of printer he had. It wasn't very big, and he had an after-school robotics program, and they were making little Raspberry Pi tanks, I think they're called. So he was going to 3D print out the tank treads and the body and all that. And he already had most of the electronics purchased, but his little printer, I think he was going to build 16 kits, and he needed something like 50 or 60 tank treads per kit. And so he reached out to the community there in the 3D printing group, and it was a really great response. He, I can't remember his name offhand, but I can look it up. I think he received, I think he's got close to everything he needs now for all kits. Because these guys with the bigger printers, like FT5s and the CR10s, they can print out a whole kit in one run, where he was having to fill his build plate several times to get it to print one set. Okay, so I've got that one tight, and I did what I was afraid of doing. I scuffed the powder coating off the frame with the needle nose pliers. Even though I was being really careful, you know, it's easy to slip down when these nuts are so small and you're trying to tighten. So if you do have a nut driver, I think it's probably a 5mm nut driver. I would recommend using that, or if you have a ratchet set or a socket set, I recommend that over trying to use the needle nose. But the needle nose, they work in a pinch if that's all you have. Okay, so we've got this done. Install the bearings. Okay, check. Ensure the nuts are tightened to the surface equally. Check if the bearing is centered in both directions. So there should be a little gap between the frame, the carriage, and the edge of the bearing. So if you hold it up to the light, you should be able to see equal space. And I've got them all right except for this one. This one's even with the bottom, and it's got a big space at the top. So I need to loosen that one up and move it a bit. And it says when you're ready, using the pliers, rotate each nut by 90 degrees. This is enough to fix the bearing without deforming it. Okay, so I need to loosen this one up a little bit, get it back into place. Okay, I've got it even, and now I'm going to tighten it up. and then I'm going to give it each one of these 90 degrees. It says rotate each nut, so each nut 90 degrees, and I'm going to approximate here. Just a quarter turn on each. Okay, so I think they're all nice and tight. We've got even space on both sides. Okay, good. So now on to step 26, and it says that I need to place the belt tightener into the Y carriage, ensure the teeth are facing the two bearings. So the two bearings are on this side, the teeth are on this side, so it needs to face this way. Secure with two MK3 by 10 screws. Okay. And the holes are already threaded, so that's nice. So what I like to do is put the screw through the printed part, and then I line it up with my carriage. And that way, it's a lot easier than trying to peek over the edge and line everything up. So I'm just going to stick it in there. It's not tight at all. And then I'll do the same thing with my other one. I kind of lift it up, see where I'm going, get it into the hole, get it started, and then I put the 3D printed piece down and tighten it the rest of the way. And I'm not going to tighten this one like He-Man, I'm just going to get it snug. So snug is usually when there's resistance, you just give it an extra quarter turn, and that should be enough. I find it's better to apply too little torque and re-torque later if there's a problem than it is to just over-torque and end up breaking the part. Okay, now we need the smooth rods. So we need all the smooth rods out of the tube. Be very careful, insert the rods into the bearings, do not apply too much force. Do not tilt the rod. If you can't slide it in easily, check and make sure they're aligned properly. If you push the balls out of the bearing, please count them. 1 or 2 balls. Missing 1 or 2 balls are okay. If they're more, consider ordering new bearings. Okay. So we need the medium length rods, the 330 millimeter rods. So this is where they're at inside this tube. Let's see if I can get these suckers out. And it's nice that they put them in this cardboard tube with each other, because it's easy for these things to fly through cardboard packages, and when they're with UPS, they're heavy, so they bang around. And sometimes they get bent. Okay, we'll just put them right over here. And then there's some wire, looks like wiring. There we go. So here are my 2 longer rods, my 2 shorter rods, and then on the end, my 2 medium rods. So I need those, and I'm going to put them in. I need to make sure that these are parallel with each other. Move this out of the way. And sometimes it helps just by twisting the rod a little bit to get it started. And they do have nice chamfers on the end. Okay, that works good. Yep, I think my bearings are aligned. Let me make sure I got it. Yep, that's the medium rod, and then the other one goes through the single bearing. Good. So this is an example of a constrained system. You have 3 points. Some printers out there are over constrained. They have maybe like 6 bearings. It's very difficult to get 6 bearings all parallel with each other. I mean, there's 3 on either side, so it's difficult to get all 3 of those parallel with each other and to the ones across from them. So this is all you need. You just need 3. Any more than 3, you're over constraining your system. So now we need to mount the Y carriage. So I'm going to get, there's one more wire loom in here. I'll put this to the side for now. Put this guy back in the box. Okay. Make sure I don't set my frame on my wires. There, get rid of these ratchets because I don't need them. And then it says take the Y carriage including the smooth rods and place it in the YZ frame. And so I think that the smooth rods are going to fit in these little holders on the back and the front, and then press them into the holders with your thumbs. And it says that the green side goes where? Let's see. This is in the front, so the belt holder goes down, and the side with the 2 bearings goes away from the power supply or towards the logo. Okay, and so make sure they're all kind of seated in there before you put any pressure on them. So mine are all good. None of the rods are resting on the frame. So I'm going to push in this side first, and then this side. And it doesn't seem like they go in. There's no snap. They just kind of slide in. I was expecting a snap, but they just slide into place. So everything's good there. Make sure this wire's out of the way. Okay, good. And then it says do not use excessive force. So they just slide right in place. So now we need zip ties. Let's see, where did I put those things? Gotta look over on my other table. They're hiding underneath everything else over here. Here they are. Okay. The almighty zip tie. I should use my knife for this. Okay, so there's little slots in here for the zip ties already. And I need 4 zip ties. There we go. And then we're going to carefully thread those through. Slide the zip tie through the holder. There's a slot. Looks like the head's on the outside of the printer, and push it through. And it looks like you want the head of the zip tie to be on the inside of the printer. So do this, and then keep rotating it through. Tighten, tighten, tighten. Okay, good. And then you can snip them off with the needle nose pliers. Ooh. I think I'm going to go get my regular snips because they're a lot easier to use. I'll be right back.
Hello? Hey.
Okay. So these snips are a lot easier to use. Please excuse our phone call there. And you can just get it right in there. Excuse me, I'll be right back. Okay, I'm back. I've got my snips. And the head of the zip tie starts on the outside, goes down and around. Okay, now I'll do the front. It says repeat in all four corners. Okay, so I just did the front and now I'll do the back. Okay, this one was kind of tight. There we go. Just rotate it right over. Don't worry if you get it tightened and it's over the middle. They slide around easy over the top of the rod. Okay, there's the last one. That was step 29. And then aligning the smooth rods. Okay, it says proper alignment of the smooth rod is crucial to reduce noise and overall friction. So I need to make sure that these, the Y holders are released on the front. And it says move the carriage back and forth across the length of the rods. Okay, so I'm going to loosen everything up and then move these suckers back and forth. So they're already kind of loose. I never really tightened them up all the way as per the instructions. I'm going to make sure they're nice and loose. Make sure this wire is out of the way so I don't shear it off here. Okay. So I'm going to move it up to the front, and it says for me to tighten it up once it's in the front. So I'll tighten the front ones. It does snug. Making sure to tighten the left and the right screw evenly. Okay, that's nice and snug. Everything still moves freely, so that's good. We'll turn it around the other way. We'll leave the carriage in the back, and then we'll tighten the screws equally on the left and the right. When I'm tightening these down, I'm just using the short end of the Allen wrench. There's no need to go crazy on these things. Okay, cool. Everything moves, there's no binding, everything is good. So now we're going to put the pulley on the stepper motor. And it says make sure the flat part of the stepper is facing up. So I've done that. Now we need the G2 pulley, put it on the shaft as shown. So we're going to face one of the set screws vertically and the other one towards the front of the printer. And then we gotta find the appropriate Allen wrench. Okay. I'm just kind of getting it on there barely, making sure both are loose so this can slide back and forth. Okay. And then I should push the pulley back until there's a slight gap between the pulley and the stepper motor, which is easier said than done. Mine's kind of sticking a little bit. Okay, yeah, there's a hub on the stepper, and so you just leave, you guys can't see that, but there's a hub on the stepper motor right here, and then so you just leave a small gap, probably just enough for the end of the flathead screwdriver to fit in. And it says do not tighten firmly, we'll get back to that later. So I'm just going to tighten these up a little bit so they don't fall out, making sure that one of them is aligned with the flat. I'm leaving those really loose. On to step 32, assembling the belt. It says turn the frame on its right side as shown. So looks like this is the right side. I'm going to face it towards myself so I can see what I'm doing. We're going to tilt it down on the front edge. It says use the bottom opening in the extrusion and gently insert the cable from the y-axis just to hold it in place. So I've got you can't see this on camera, I've got the wires kind of tucked into this extrusion next to the foot back here. And so check, got that done. Now we pull out the belt. So this is the G2 belt right here. So we've got that. The 650 millimeter y-axis belt. Insert one end into the belt holder. And you're using the upper slot. So the ribbing, these little teeth go down, they're facing down. Insert it into the belt holder with the teeth facing down. Check. Okay, got it. Press it all the way, use an Allen key or a slotted screwdriver. So I've got it all the way in there. It's nice and snug. That's going to prevent it from being pulled out. Then I'm going to loop the other end around the pulley in the front with the teeth on the belt facing towards the pulley, making sure that there's no twists in the belt. I don't want it to get all twisted up. I want it to be nice and flat, which is easier said than done. I think I've got a kink in here already. So I'm going to flatten the whole thing out and then put it through. Pull out the slack. Okay, success. And then guide the the belt it goes over the frame. There's like a little V in the frame right here, and it goes over that. And do not put it through the holder, the belt holder. It goes over the rear plate, not below. So it goes over this plate in the back. And now turn it on its feet. And it goes over this pulley, or around this pulley. I'm going to go ahead and pull it all the way up to the front. Goes around the pulley. And then back into the belt holder. So I think I'm going to tilt it over again just so I can get a better look at it. Very gently, making sure I'm not putting too much pressure on the carriage. And I'm going to insert it into the belt holder. So it doesn't go all the way, it's not flush with the end, so just get it as far as you can. Press it all the way in with a screwdriver or an Allen key. So we're just going to push it all the way in. Mine's nice and snug. The belt should be stretched and not easily bent. So I've got mine pretty taut. So that was pretty easy. So now we have to align the axis. So I'm going to put it back on its feet, so to say. And we're going to align the, oh, remember to take the wire out of the the extrusion. Okay. Yeah, I can see that it's a little bit off kilter here. So I'm just reading the instructions to make sure that I've got everything in there correctly. Make sure the belt is placed in the axis of the printer. Okay. To adjust the belt position, release screws on the pulley and move it and slightly move with it until you reach the best position. Okay. So you move it left and right to make sure everything is perpendicular to the frame. The belt should be parallel with the linear rods and perpendicular with the front and back plates. So if it's not installed parallel, check to make sure the belt is properly inserted into the Y belt holder. So that's why they told us to use the screwdriver to make sure it was poked all the way in there. Mine looks pretty close. It's probably better to stand up and look straight down, and you can see. So if you look down, there's little holes right here. And mine looks like it's a little bit too far over. So I'm going to press, going to find the screw holes in the pulley mount. I'm going to loosen those up. That way I can adjust it. And you could just move the carriage back and forth. And then whenever we're ready, tighten both screws on the pulley. So it just needs a slight adjustment. And I got to make sure that it's not touching, make sure that pulley is not touching the stepper motor, because that's going to create a lot of extra friction. There we go. Okay, I like that. It looks pretty good. I'm gonna go ahead and tighten that down. I like to tighten the set screw on the flap first, give it a nice torque there, and then secondary, the one on the side, the one on the round part of the shaft. Okay, so that's done. On to step 36. Using Allen keys, I need to tighten and release the screws on the front to make sure that the belt is properly tensioned. So using a finger, push the belt down. So you should need some force to bend the belt, but don't overstretch it. So you should be able to pluck it like a string on a guitar, like a bass guitar maybe. So it doesn't need to be so tight that it's high pitched, but it does need to have some tension on it to make sure that it engages with the teeth. Making sure they do the top and the bottom. And don't worry if you don't get it set perfectly. You can always come back. Since this is on the front of the printer, you can always come back and do it later. And the main thing you want to avoid is overstretching the belt. So that looks good. So we need to test the Y belt. So we need to make sure it's properly stretched. Use pliers to turn the stepper driver. No need to use excess force. If the belt is properly stretched, you should feel resistance, and the Y carriage won't move at all. If the belt is too loose, it will deform and create a wave. Okay, let's give that a shot. Okay, it looks like it moved. Oh, I hold it and then I move the axe. Okay, that makes more sense. So I hold this and then I try to move the axis. And so I'm holding it and I'm pushing on the carriage and nothing's happening. So if it's too loose, the belt will jump over the teeth on the pulley. If it's properly tensioned, you'll be able to resist it with the needle nose pliers. Okay, so mine's properly tensioned. On to the next step. The Y-axis is finished. Okay, so it says Y-axis is done. Great job. Open the bag of gummy bears and treat yourself. So I like that. I think I'll do that. And then look at the picture and make sure everything is done. Great. So they've got a little button here on the finish line. I can hit check. I'm finished. Okay, so I'm going to stop for now. That's section 2 of the assembly. We're assembling the Prusa i3 Mark III, and we've got the Y-axis done. So thanks for watching. Feel free to post any comments in the comment section, and we'll be back for the X-axis next. Thanks.